So today we are going to start with unit number 6, that is dimensional analysis and similitude. So we will discuss the syllabus of unit number 6, that is dimensional analysis and similitude. So you can divide this unit into again two parts. The first part is dimensional analysis and second part is similitude and model testing. Okay. So in dimensional analysis, we are going to see what are dimension, what is the system of dimension, dimensional homogeneity, Buckingham pi theorem, and we will going to solve the problems on Buckingham pi theorem. Okay. Then second part is similitude. So in similitude, we will see what is model, what is prototype, how to establish the relationship between model and prototype. Okay. What are the different models law and different dimensionless numbers. Okay. First of all, we will see what is dimension analysis. So dimensional analysis, as the name indicates, it is a method of dimension. Okay. So basically it is a mathematical procedure which is widely or extensively used in research. Okay. Now what happens in modern dimensional analysis, uh, see, when you conduct the research, okay, you don't know the result, what result you are going to get. Okay. So suppose we are performing any experiment, for example, Reynolds experiment. Okay. So in Reynolds experiment, what you are doing, uh, in Reynolds experiment, there is a pipe. Okay. Water is flowing through this pipe. Okay. And what we are doing, we are taking one ink arrangement and we are giving the ink at center. Okay. So we are discharging the ink at center and water is also flowing through this pipe. Okay. And this water is collected and time required to measure to fill the particular volume is measured. Okay. So what happened in this technique, in this method, whatever the volume collected per unit time, so we will get the velocity, we will get the discharge divided by area, we will get the velocity. Okay. So what is the relationship between velocity, diameter of pipe, okay, and whatever the density of liquid. Okay. So all this we can calculate with the help of one dimensionless number, that is called as Reynolds number. Okay. And we had seen this Reynolds number is velocity into diameter divided by kinematic viscosity nu. और ये रेनॉल्ड नंबर आई थिंक आपने फर्स्ट प्रैक्टिकल में भी कैलकुलेट किया है. ओके. सो हियर in this experiment, whatever the result, whether the flow is laminar flow or turbulent flow, you are going to decide with the help of one dimensionless number, that is Reynolds number. Okay. So in dimensional analysis, such dimensionless number which governs the flow. ओके. जैसे यहाँ पे रेनॉल्ड नंबर डिसाइड करेगा कि आपका लैमिनर फ्लो है कि टर्बुलेंट फ्लो. इफ इट इज लेस देन 2000 इट इज लैमिनर फ्लो, इफ इट इज मोर देन 4000 इट इज टर्बुलेंट फ्लो. So एक dimensionless number कंट्रोल कर रहा है. ओके. So such type of dimensionless number which governs the physical fluid flow phenomena, they are basically derived using the method of dimensional analysis. Okay. So in engineering, in heat transfer, fluid mechanics, turbo machine, okay, in various subject you are going to see this method of dimensionless number. आपको आगे बहुत से डेरिवेशन आएंगे यहाँ पे dimensionless number का मेथड. I think in unit number 1 we had seen the system of dimensions. So quickly we will revise it. Okay. So what is dimension, or what is the classification of physical quantities? So physical quantities are classified as primary or fundamental quantities and secondary or derived quantities. Okay. So fundamental or primary quantities are the quantities which does not depend on any other quantity for their existence. Okay. For example, mass. Okay. Mass, suppose mass of 1 kg. Sorry. Suppose mass of 1 kg of a particular body. So it can have a spherical shape, its mass will remain 1 kg. It can have a cubical shape, its mass will remain 1 kg. Its shape can be triangular shape and it can be 1 kg. Okay. So it is not depending on dimension. Similarly, it may happen mass at 10 a.m. is 1 kg, 12 a.m. पे भी 10 kg रहेगा, इवनिंग में 6 p.m. पे भी 1 kg रहेगा. So it is not depending on time. There are some quantities which does not depend on any other quantity for their existence. So such type of quantities are called as primary or fundamental quantities. So basically, there are four fundamental quantities, that is mass, dimension or length, then time, and temperature. Temperature is denoted by theta. Okay, but this temperature, it will going to vary, or the remaining properties will vary for the case of gases. Okay, so in case of gas, for a small change in temperature, for 1 degree change in temperature, there is a large change in mass or dimension. Okay, so gases के केस में हम थीटा को कंसिडर करते हैं, बट फॉर द केस ऑफ लिक्विड, okay, for a small change in temperature 1 degree or 0.5 degree, there is no much change in other dimension. Okay, so basically for liquids we are going to take the system of mass, length and time. So this mass, length and time, these are three uh, primary or physical quantities. Okay, and any other system where heat temperature involvement is there, so in that case you can also take theta. Okay, and basically it is taken for gases. Okay, then in addition to this fundamental or physical quantities, there are other quantities such as velocity. Okay, velocity, then density, then viscosity, etc. So they will require more than one quantity for their existence. For example, velocity. Velocity is distance upon time. Okay, so suppose same time रहा 1 minute के time में distance आपका different है. For example, in 1 minute one body is covering 10 meter, in another body, or in other case other body is covering 20 meter in 10 seconds. Okay, so in this case, in both the time same 10 seconds, the distance traveled is different. Okay, so in that case the velocity of both the bodies will be different. Similarly, if the distance travel is same and time is different, so in that case the velocity is also different. Okay, so velocity is depending on two other quantities for their existence, so it will be secondary or derived quantity. So all the property except mass, length, time and temperature, they are secondary quantities. Okay, and definition of dimension is, it is a mathematical representation of secondary quantities in terms of primary quantities. Okay, जैसे आपने velocity को mathematically represent किया in terms of primary quantities. Primary quantities कौन सी है? हमारे mass, length, time. Okay, so इस फॉर्म में आपने डिनोट किया, so it will be called as dimension. Okay, so it will be called as dimension. Okay, so dimensions are always indicated in square bracket. Dimension को हम square bracket में दिखाते हैं, and they are denoted the by index m to the power a, l to the power b, t to the power c. Okay, so I think all this we had seen in first unit, and first unit में हमने सारे properties के dimensions भी denote किए थे, calculate किए थे. Okay, remember the fundamental quantities are length, mass and time. So length का symbol है L, mass का symbol है M, time का symbol है capital T, and the dimension or length dimension is m0, l1, t0. Dimension of mass is m1, l0, t0. Dimension of time is m0, l0, t1. Okay, after that this is one table which will give you the different properties and their dimensions. Okay, so ये जितने भी properties है ये आपको याद रखने हैं, इनके dimension याद रखने हैं, because they will be required for solving the problem. आगे हम जो प्रॉब्लम सॉल्व करने वाले हैं उसमें आपको ये सारे डायमेंशंस का यूज होने वाला है. ओके, सो एरिया इज नथिंग बट इट इज अ प्रोडक्ट ऑफ ब्रेथ इनटू हाइट. सो इट्स डायमेंशन इज m0, l2, t0. डायमेंशन ऑफ वॉल्यूम इज breadth into height into width. Okay, so it is m0, l3, t0. Similarly, velocity. So velocity is meter per second unit is, okay, distance upon time. So m0, l1, t minus 1. Angular velocity. Okay, so its unit is per second. Okay, or radian. So its dimension is t minus 1. m0, l0, t minus 1. Acceleration meter per second square. So l1, t minus 2. Again, आप बहुत से यूनिट से भी डायमेंशन पता कर सकते हैं. जैसे एक्सेलरेशन इज मीटर पर सेकंड स्क्वायर, सो m0, l1, t minus 2. ओके, Acceleration. Angular acceleration is again t minus 2, m0 l0 t minus 2. Discharge. Discharge is meter cube per second, so L3 t minus 2. Okay, यहाँ पे L3 m का क्वांटिटी नहीं दिखा है, so basically it is m to the power 0. Okay, यहाँ पे m और l नहीं दिखा है, so it is m0 l0 t minus 2. Okay, so ये जितने भी प्रॉपर्टीज है ये आपको याद रखनी है. Okay, so these are the geometrical properties, these are kinematic properties, and these are dynamic quantities. Okay, so इनके डायमेंशन आपको लगेंगे for solving the problem. After that, we will see dimensional homogeneity. Okay. Now, suppose there is any equation. Okay. Suppose there is any equation. For example, Reynolds number. Reynolds number is equal to, or you can say discharge. Discharge equals to area into velocity. Okay. So, if we take the dimension of LHS and RHS, okay, so it will be dimension of discharge, that equals to dimension of area into dimension of velocity. So dimension of discharge, what is the dimension of discharge? It is m0 l3 t minus 1, okay, meter cube per second. Okay, so that equals to right side. Right side is area, so area is m0 l2 t0. Okay, then velocity. Velocity is meter per second, so it is m0 L1 1 t minus 1. ओके, सो अभी हम इन दोनों को ऐड करेंगे. सी इनका जब भी प्रोडक्ट होता है, व्हेनेवर प्रोडक्ट इज देयर, सो जो टू द पावर होता है उसमें एडिशन होता है. ओके, और जब डिवीजन होता है तो टू द पावर में सब्ट्रैक्शन होता है. सो बेसिकली यहाँ पे मल्टीप्लिकेशन है एरिया और वेलोसिटी का, तो इनके पावर का एडिशन होगा. So it is m to the power 0 plus 0. So it is m to the power 0. L to the power 2 plus 1. So it is m to the power L to the power 3. Okay. And t to the power 0 minus 1. So it is minus 1. T to the power minus 1. You can see the dimension of RHS. M0 L3 t minus 1. That equals to dimension of LHS. M0 L3 t minus 1. Okay. So if the dimensions of right side of the equation and left side of the equation, they are same, that type of equation is called as homogeneous equation, or you can say it is dimensionally homogeneous. Okay, so dimensional homogeneity means the dimension of each term in the equation on both sides, they are equal. Okay, that means whatever dimension to the power, okay, on left side and right side, this should be same. So if the dimension of each term on both sides of the equation are same, then the equation is known as dimensionally homogeneous equation. Okay, that means in dimensional homogeneous equation, the power of fundamental properties m, l and t, इनके जो पावर होते हैं m, l and t, इनका लेफ्ट साइड और राइट साइड का जो वैल्यू है वो सेम होना चाहिए. Okay, then such type of equation are called as dimensionally homogeneous equation. Okay, so consider the equation v equals to under root of 2gh. Okay, now the dimension of left hand side, that is velocity, it is L1 t minus 1. Dimension of RHS, that is under root of 2gh. So it is under root of, okay, g का वैल्यू क्या आता है, मीटर पर सेकेंड स्क्वायर. So under root of L upon t to the power 2. Okay, or L1 t minus 1 into L. So it will be L square by t square. Okay, इसका स्क्वायर रूट है तो स्क्वायर रूट के साथ स्क्वायर कैंसिल होंगे. So it is L upon t. So it is L1 t minus 1. Okay, so you can say the dimension of LHS, that is velocity, is L1 t minus 1. Then the dimension of RHS, that is under root of 2gh, that is also L1 t minus 1. Okay, therefore you can say the above dimension of LHS equals to dimension of RHS. Therefore V equals to under root of 2gh is dimensionally homogeneous equation.